should say good evening now. I think some of you have been here early hours in the morning. And I thank you all for inviting me here to present what we have been doing in academia, as well as we try to take that outwards to the community and sharing what we know, the bit that we know to the rest of us. I've attended a few lectures, both yesterday and the day before, and I think the range of the speakers varied from the theoretical all the way to the practitioners, and the objects that they were designing varied also from a piece of jewelry that much to a building and a mosque. And today I'm presenting neither nor. What counts today is the line of thought that I'm trying to inject in our societies, especially our dear students. We tried maybe also 4 years ago, maybe a little bit more. I personally tried to think, how do designers and architects think? What goes through their minds? What generates their ideas? We had run a whole conference on that issue. It was called Sources of Architectural Form, Theory and Practice. So we're basically thinking, how do these people get inspired? How do designers, interior designers, musicians, architects, but we had a focus on architects. And the answers were all the way from mathematics, where sheer technical issues, where logic is there, all the way to poetics, where history and nostalgia and even poems were generators, and adjectives of objects were the engines behind these thoughts. Okay, well, after that we said, okay, what else can we do in this? And I tried to be a theoretician. And sometimes I fail, sometimes I succeed. But how does an idea go into a theory? I'm not going to bore you with a lecture, but I will highlight just the main ideas that I'm trying to push, and then it's going to be more fun with images and videos, hopefully. So how does an idea turn into a theory? I think an evidence-based experiment. So if you do an experiment and you provide evidence, and if it lasts for a while, and nobody is going to jump on your shoulders and going to say, no, your experiment is false, then boom, you have an idea, or you have a theory. Or is this not in sequence? Yeah, I didn't know. So the first idea that I was hopefully transferring into theory was to bridge the gap between architecture and technology and fabrication of that. Again, I hesitate to say buildings, but I want to concentrate on the making of objects. Again, let it be a ring or a building or a high-rise building. So I think there is a strong link between what we design and, more importantly, is how to fabricate. Again, from the previous lectures that I have seen here, there were a lot of struggles of making errors and going back, and so it's a continuous feedback between the making and the design. The next idea is that computers can supersede the human mind by many folds. Yes, lots of ideas got created from human brains, but when it comes to perfection and retrieving these data and information, I think computers are much more superior than the human mind. So therefore, we tried to have that in mind, and we did this experiment with the students to prove that point. The third idea is that computers can be used all the way from the very stages of design. We try to present the idea that computers are not used just for pretty picture image making, not just for rendering purposes, but we use computers for the purpose of design from the very early stages, from day one, all the way to the final product, all the way to the production of that product. And again, if I want to prove that theory, I have to present evidence. And in my pavilion, it's not my pavilion, it's our students' pavilion, I think we have enough proof that we've used computers, we presented these interesting theories and theorizing, and now we want to prove them. And last but not least, idea that I think, personally, design is change. And by that I mean, in any design endeavor, the designer goes through many phases of change back and forth. They keep modifying stuff. But what's more important is when you make a change in one little corner of that object that you're designing, the rest can change, and it has a ripple effect in areas that the human mind cannot comprehend instantaneously. So we use computers to give us a clear indication and direction of what can we detect in terms of changes when we change one issue in the 3D object that we're working on, while still being able to control the fabrication part and the production part. So I don't want to take too much of your time on that issue. I think we need to prove those and solidify our theorizing into materiality. Where are we?
Second one.
First one.
So presentation or video?
Presentation. Yeah, this one.
Did you open it before? Did it work?
Yeah. Should we double click on it?
Yep.
Maybe Shahid? Maybe?
Shahid? Can it's already open? Huh? It's not. It's not. حتى it was opening a few. Okay, let's open. Technical issues? We'll be right back.
المشكلة إن كلهم يصيرون بوقتي أنا. I must be jinxing it.
Can we quit Adobe إذا مفتوح? Let's do this. Yeah, first quit. Yes. Yes, and then we should open it again. There we go. Okay.
Thank you. So to prove our theorizing, I thought we should prove that. And like I said at the very beginning, you cannot defend your theory unless you have provided enough evidence. But please don't take this as a building. Think of the ideas that I'm trying to present when you see these display. I have to truthfully say that before we get started in this project, we were very hesitant. Hesitant in many ways. There were a lot of software learning that had to be done in the studio, and the students were complaining whether, are we going to learn software or are we going to learn design? Do we have enough time? And then we got into the fabrication process. Who's going to create these? Who's going to create these objects for us? I was scared to go through this experience with the students. Again, these are students that I have not dealt with before, nor the scale of the project made me comfortable going through this. But I think we said, let's give it a shot and go through it. I think at the end of the course, I think people were very happy, and there were even students were bragging off and showing other students what they can do and stuff. So I'm very happy that we went through the experience. So these are just either models, miniature models, or the images from the actual pavilion, and just show you some excerpts of and how they started with a concept and an adjective, and it happened to be a creature, a snail in that case, and they were learning some characteristics of that snail, and we were wondering, how does the snail move? We did a little research. We found out that it moves by vibration. It finds its way by vibration, and this got translated into design. This is the technical part where we used somewhat advanced softwares called Rhino and Grasshopper, where the students kind of generated many variations of these forms in order to decide which form would work best to translate their concepts and ideas. But more importantly is the fabrication part. How would we produce such an object in that scale? What materials would we use? What are the behaviors of materials when they are up and loaded by the stresses on the building, on the structure, on the object? So there was lots of dialogue going back and forth, and we were also trying to insert, a little more detailing and conveying the idea of how does the snail finds its way around, just like how sound would be captured through images. It was very challenging too, but this relates very much to the topic of this very conference here, where we can introduce the arabesque and the detailing on our projects, let it be 3D, let it be 2D, and even 4Ds in some cases. If you capture sound, I think that's a 4D to me. Now, primitive experiments in the university where we were checking the form, there were no single pieces of wood that would cover that much span, and no single, I don't know any tree that is shaped that way where I can, steal that shape and use it in our pavilion. So therefore, we had to break things down into little components, as you see here maybe in the geometry. Do I have a laser or no? I guess not. So you see the variation in color. This tells you that these are different strips that have been assembled together to create that geometry. The making of that geometry was, I could confidently say that, very, very, very precise. We're going to, I would say, 98%. This is very darn good for primitive kind of technology that we have here in Kuwait. But again, in order to get that precision, we had to go with computers to produce this kind of geometry. Each single one of them is not similar to its sister sitting next to it, or brother, I should say. Each one has its own dimensions. They were produced by an automatic command in the computer where you would slice up that geometry into slides, and then they were broken down into components. They were sent to a fabricator, a machine, and then were recorded where each component would fit exactly to create that overall geometry. They were numbered, not to lose the sequence of these components, so that they can again be attached to the same location, as well as the order in the overall geometry. They were cut from straight panels, and we were trying to best fit and optimize the wastage, we were trying to reduce the number of boards that would be wasted from our project. And we use also nested software that can optimize this for us. Now these show you more pictures in the making. I apologize for my students. They were all over Shweikh, especially females of them. There was not a comfortable environment, but I think they have learned a lot. in many fashions, how to deal with people, as well as resources. Where can they find what in Shueikh? And I think if you master that, you have hit the jackpot. Shueikh. So I will just proceed quickly because I have a lot of other images. And this was, the pavilion was assembled in Al Raya, where they have allocated a space for us. I thank them also for that invitation and their strong belief in us. We also chose Al Raya for another purpose, which was to experience the pavilion from an elevated level. So you could go to the second floor and the third floor and capture views of the pavilion. Otherwise, you would be very much far off to experience those images from those directions. This is more pictures of putting units together in the hallways, and this all was done after 10 p.m. So we had to pull it an all-nighter in some cases, many cases actually, where shops had to be closed and we had to work. Again, I'm not going to comment on the design per se, but again, I think this fits nicely to the theme of the conference here, of the details. If you want to go on to the light, the light interpolation and the experience of light and the journey as you go through this pavilion, I think it's amazing if you come the daytime versus the nighttime. We tried to create this very image that you saw previously of someone screaming on this. This is this is an image of a human face. I think if each direction you take this picture, it keeps changing on you. And this is the idea of the vibration and the sense of sound as you experience the walk through. We had even some details on the floor where you have calligraphy on the floor and poets that are related to the main concept of the students' original concept. Okay, how do we go to the second one?
This is the clip if you want to play it.
Yeah, the last one.
Do you want to play our video or the clip of the rhino?
Rhino. Let's start. I just want to show you the procedures of in the making, the design of the pavilions, and how much we went back and forth to modify and verify the fabrication process and the structural issue of this pavilion. Why is this Is it running?
I think it's still. No, it's still running. It's loading our computer.
I stressed on, and I insisted in showing you this because to show you that if we change one area of the pavilion, the rest could change in terms of either spacing between the slices or the geometry would pop up and go down, and we have to really test that again from an aesthetic point of view, whether we like that or not, and also from a fabrication point of view, can this stand, can we put the pieces together, and more importantly is, how are we going to assemble these units together? Is it going to be a strong visible component, or we're trying to minimize the connector's visibility? So I'll stop here. And finally, for this very pavilion, each students were responsible for making a video of their work. This is probably 10:30 p.m. We're not done yet.
That video required an applause.
Okay, so wait a second. And now we go to the second pavilion. And mind you that I haven't mentioned that the class was made up of around 30 students. And we could not, of course, make 30 pavilions due to time limitation, to money availability, funding, and so forth. So it was run through a charrette design where it's a small mini competition between the students. They were ganged up into small groups. We had 15 groups of two. Was it two? I think so. Initially, as a design concept generators at the beginning, we had a competition within the class, and then we selected two main winners, and we decided to enslave the rest of the students for the main designers. I'm just joking. It's not an enslaver. Each one of them had the design privilege to be associated with that project. So there were each pavilion had 15 students working on that, all the way from the design improvement in the later stages, all the way to the production and the display and the making of the event and the organization of the event. So this is the second one. It's called Hexagon or Pavilion 6. And again, it was generated from nature in that case and the sea urchin. And it's an amazing geometry out there, as you may well know or have seen on TV, National Geographic and so forth. But I think we put that in place now. We've learned from nature. But that's not what's important. What's important is how can you make that and fabricate it into a pavilion. A sea urchin is this big. The forces on the sea urchin are way different from the forces on the pavilion. And we're not designing for animal shelter. We're here to display the design capabilities and the appreciation of the arts. This is what pavilions are for. There are so many people in Kuwait that came to us and say, okay, بعدين شنو هذا? But after the pavilion was displayed and the event started, then they understood, and there's a culture behind it of, an awareness of the display of and the appreciation of the arts. Again, processes and procedures of how did you come up with that hexagon. It happens to be a very geometry friendly to create a very volumetric surface, and later on to assemble it up into like a very dome-like geometry. Again, each one of these are different from its neighbor, but it has to be made perfectly well, that it fits nicely in place where the joinery was using just glue and a little bolt. So if you are off by 1 centimeter, you are doomed. So we have to deal with this accuracy of fabrication from day one. We have to make sure that this is what's happening. It's not to say that we had a perfect situation. There are many conditions that prevented us from producing a 100% perfect design. Let it be the material behavior and the storage and the assembly and the glue مو موجود بشويخ, let's go order it or find it somewhere else. We also have to change the geometry because of the fabrication limitation, and that's the beauty of it. I think that's a plus when you work with computers and modeling, digital modeling, where we can quickly change our minds into plan B, let's say. These are just initial geometries that we're trying to place panels that are very hexagonal into a smooth surface. And there are many calculations that are embedded in those. And most of these panels are finger jointed. I don't know if you're familiar with finger joints. So pieces that inner joined, just like the Mamlukis or the Egyptian woodwork where they don't use nails into their joineries. This is almost like that, where the ends of these panels are designed to fit together in a finger joint in order to prevent the mechanical fixations. These are just images of the pavilion, and I think, again, to remind you of why we are here, I think this fits very nicely well with the theme of the conference in terms of the folding of these each geometry. We had the capabilities of unfolding these geometries into a flat components and then sending them into a machine that reads these files, cut them, and then more importantly fitting them together. That's very Arabesque to me. That's very, it's almost like equivalent to a calligraphy. Let alone the additional little details that we have introduced in the perforations in these panels. And these were following a parametric approach where we take a pattern and try to fit it on faceted surfaces. These are not smooth nor, not straight nor perfectly curvaceous. They are very bumpy. And it was challenging for us to place these patterns in order to follow a certain path on these very complex geometries. This was the opening day, I think, or 2 days after the opening day. So we're going to talk about light and, the theme and the concept, but this is not my purpose here today. Again, this is the detail that I'm talking about. There is no way أتحدى أي نجار بيده بيشتغل بهالنظافة, بهالfixing, بهالاccuracy. You know how many of those are there? It's not the numbers, it's not the sheer number, but the accuracy of the fitting, أعتقد, which really let us fetch for softwares that can do this, and we found those. So this is the خلينا نقول الخردة, loose materials, where after we send them to the cutting machines, the CNC machines, and also we have used softwares that can analyze the thresholds and the stresses on this geometry, because this is very organic and very irregular. It's like an egg shape. It's not exactly an egg shape. This is a dome, not exactly a dome. وفيها facets. والmaterial are only 8 millimeters thick, plywood board, no nails. So it was scary. But again, we used our common and expert knowledge in some cases, where we use software that can even analyze the stresses on the structure. So you take the geometry, not the real one, but the one you have made in the computer, and send it to another computer that can analyze the forces on this structure. And these are my poor students at the bottom. This is the software, the structural analysis that we have done in the geometry. Again, before it was done and before it was too late. Because there are many situations in Kuwait I'm facing, and now they go very far off in the execution process, and they found out only later that there's a problem in the execution. So we try to manage that early on. Again, this is maybe another 10 p.m. or it's nighttime, I know for sure, because they can only allow us work in the nighttime. So the initial stages, حتى assembly, we had to think about, do we start from the top, go down, and how would that be? To have a scaffolding in the center, or do we start in the bottom? Okay, if it's in the bottom, do we go into strips? ولا strips arches this way? فلازم كانت تكون rehearsed very, very, very well in order to put them accurately together, as well as prevent it from failure. I think that's me on the top. Is it? The scale-wise, this is like 5 meters high, and 12 meters long, and 7 meters wide. You might ask me why these dimensions. I tell you, and we went to the site and checked how big can we have of a pavilion, and whether this pavilion is big enough to make a statement. So this was, again, modified according to the conditions in the site. There's a little mini model that we produced very quickly when we tested before the actual structure was put together. I also want to share with you, as ما يزعلون جماعة الهexagon, and we're going to do a movie also. I think. This is what I mean when I say, again, computers were used as a design tool and not a rendering machine. Again, this stuff is not easy if you don't know like scripting or the software itself. But after you're done with little, very small, minute changes, you can do a lot of options that you can expose to yourself as aesthetics, or as fabrication, or structures. Initially, we produced panels, hexagons, that are 3 meters long or 2.5 meters wide. And we thought, how are we going to carry this? Is this doable? Is there materials that can cover that span? Then we found out, the method of assembly was associated with putting them together piece by piece. How are we doing in time? I think I'm going to open this last. Primitive way of posting first. وأنا الضحية الأولى. These panels are only 8 millimeters thick, so I think it's a good size that we did with it. Each panel is numbered to fit exactly where it belongs. And this was done through the computers, numbering auto. There was no manual numbering as well. كلها done by the CNC machine. This is an example of group work. We also continuously had our computer screens open so we can check our coordinates of how high the things are compared to what's happening in the model. So in order for things to meet nicely. It's almost like a GPS, a 3D GPS. sorry to take that long. أعتقد the message for me is very clear. It's the process and the technology that's out there. Let's use it. I could care less about the pavilion geometry. It's what counts is what we can do with the technology in order to create any building type. Let it be a bus station or a public sculpture or even a high-rise building with this technology. I thank you, and I will take any questions now.
Yes, thank you, Dr. Hussain. Any questions?
First of all, Doctor, I would like to thank you for this effort. I mean, this is excellent, one of the best things I've ever seen. Just a comment and then a question. I think what I noticed there is we tend, when it comes to Arabesque, we always, Arabesque design and industrial, let's say, on the level, we always tend to think Arabesque is a handmade, it has to be a craft, artisan thing. But I think from what I noticed is the technology is out there. I mean, if we take something on that level, on that scale, we can take the beauty of our design on an industrial level. And I think yesterday we've seen a very good example. I mean, Yunus is one of the guys he's coming from industrial background design. He managed to take this on industrial level, take these beautiful designs because of the use of such technologies. So, I mean, it's out there. I don't see why we, in this part of the world, why we don't go to that scale, use these technologies, and we'll be able to communicate and produce on a mass production level, because we tend to think mass production is not really Arabesque. I don't see why we can't do mass production with Arabesque, why we can't have another IKEA, for example, which is purely on our beautiful designs on a mass production. We can go globally. So it doesn't have to be really handmade, specific, different pieces. We can go on that level. The question I have also is, I think one of the frustrating experiences we have on the consumer level is whenever you want to have a design, even a small stuff, you don't find in the market, you don't find people who are educated enough to use such tools and technologies and approaches to design what you have in mind. So usually you want to build something, you go into this frustrating experience of the joints are not coming together, it's not, you discover that later on. So are you doing anything from your side as an educational institute to try to educate the community of the manufacturers and the designers, and let's do something that really could improve this industry as a whole?
Okay. I've been trying to inject this, like I said, from the very beginning of the conference in 2007. Again, I deliberately introduced that topic because I want to tell people that there are other ways of approaching design. One strong thing that we are lacking in our part of the world is the technology and the computational methods, I should say. Most of these high-end designers, signature architects, use this very technology. Zaha Hadid does that, Foster Group does that. This is not new. Besides, this has been used in the automotive industry, in the ship making, in the architecture, and the arts are way behind. So I think there are a lot of people are learning from other disciplines to incorporate this technology in. So I still think this is humane. And because I have some criticism of that, and you're not designing, you're letting the machine do that for you. And I think there are many decisions that are associated with what we have done is like started with a sketch. وحتى بالعكس أنا أقول لك don't start with a sketch. Start with a 3D geometry من الكمبيوتر على طول, where you can generate alternatives. And to go back to your question, is again from that very conference, I think people saw the idea that there are many approaches. Without proving, I had no theory. Remember, I thought idea. But when you do a project, you have a theory. And وبعدين يجي واحد ينسف الثيوري or stresses or يعني يوثق الثيوري. يقول لك أنت you're done. So I think I started. I don't claim that this is perfect, well, it's a perfect theory. These are good examples to show that there are more than one way to arrive at design, and especially computational. And we can go to the micro level, which is I can take the manuscripts of any religion and I can put parameters on it. Don't go 2 dots على left, أكثر من 2 dots على left, but stretch this way or go on a diagonal fashion. Thickness of the line should not be less than this. حتى I can introduce many factors such as 3D-ness of these manuscripts. Let it be Kufic or what have you. So I think the idea of incorporating digital computing should be way out there. And I thank you for that question.
Hi. I think the most interesting part about the pavilions is the fabrication process that it went through. And it had interesting moments of sequence, the interplay of light, the threshold, you know. Design, because here we started with form. You know, there was the form of the snail and all of that. That was what generated the pavilion. And in design and buildings, you have function, and function meaning more than pragmatic function only. You know, the social, cultural, economic, light, space, all of that. So how do you answer that?
Okay, if you want to go for, do you know the definition of a pavilion? Pavilion is there, again, as a shelter where people congregate and gather to appreciate the arts or the profession of, let's say, interiors or architecture. There are pavilions that are held every year in the Serpentine Park or next to the Serpentine Lake in London, where, again, a lot of famous architects do these pavilions. So this is not a new thing that we're creating, but the function of that, if you're looking for a function, is for people to gather around it and appreciate the little details and the wood materiality and the inner form as well as the exterior. So you're looking at art and not being necessarily the tangible material, but the void and the space. And there was a concept behind it where, again, the sound generation and the capturing of the sound for the snail case, and the geometry, and I don't think there's nothing wrong with the geometry if it starts with as a generator of an idea, a generator of a form, or a generator of a project. So you have a function where people gather and chat and meet, just like a gallery where you go and what's a gallery? That's a temporary gallery. A gallery of the art and a gallery of the materiality. Question?